Since 1995, one web server has powered more websites than any other: Apache. It is the backbone of the LAMP stack. It runs WordPress, Laravel, Drupal, and most of the shared hosting on the internet. This chapter explains what Apache is, what role it plays, and why developers still use it in production today. Apache HTTP Server is open-source web server software that delivers web content through HTTP and HTTPS. It is the A in the LAMP stack: Linux, Apache, MySQL, and PHP. Apache sits in the middle of every request. The browser sends a request, Apache receives it, Apache passes it to the application queries the database, and Apache returns the response. The browser never talks to PHP or MySQL directly. Apache is always the entry point. 3 reasons developers choose Apache. First, it is everywhere. Most shared hosting environments run Apache. If you upload a PHP project to cPanel or a shared host, you are on Apache. Second, htaccess. Apache supports per-directory configuration files. Laravel, WordPress, and nearly every PHP framework uses htaccess for clean URL routing without touching server-level config. Third, modules. Apache's module system lets you add features on demand: SSL, compression, rewriting, proxying. Enable only what you need. WordPress alone powers over 40% of all websites. The overwhelming majority of those run on Apache with PHP and MySQL, the classic LAMP stack. Laravel projects use Apache with allow override all to enable htaccess routing. Drupal and Magento follow the same pattern. Development tools like XAMPP, WAMP, and MAMP bundle Apache, MySQL, and PHP together. Most PHP developers start their careers writing code locally on Apache. Apache uses a multi-processing module, NPM, to manage how it handles connections. The prefork NPM creates one separate process for each incoming connection. This is the safest option for mod.php because PHP is not always thread safe. The worker NPM uses threads within processes, more efficient. The event NPM is the modern recommendation. It handles keep-alive connections without blocking worker threads and pairs well with PHP FPM. Unlike Next, which is fully event-driven from the start, Apache's prefork spawns one process per connection. Under very heavy load, this uses significantly more memory. Apache is the LAMP stack's web server. It handles HTTP requests. It runs PHP via mod.php or PHP FPM. It supports htaccess per directory configuration. It powers WordPress, Laravel, and most shared hosting. It uses NPMs to manage connections, prefork for compatibility, event for modern performance. Every time someone visits a website powered by Apache, 6 things happen in sequence. Each step has a specific job. Miss any one of them, misconfigure a virtual host, forget to set allow override, point document root to the wrong folder, and the request fails. This chapter walks through all 6 steps so you understand exactly what happens between URL and rendered page. Step 1. The browser sends an HTTP request. The user types example.com. The browser performs a DNS lookup to resolve the domain to an IP address, opens a TCP connection, and sends the request. The request contains the HTTP method, getPost, the path, the HTTP version, and headers like host and accept. Step 2. Apache receives the request. Apache is always listening on port 80 for HTTP and port 443 for HTTPS. When the request arrives, Apache reads the host header to determine which domain is being requested, checks the path, and looks up the server configuration to decide what happens next. Step 3. Virtual host selection. One Apache server can host dozens of websites simultaneously. Apache compares the domain in the host header against the server name in each virtual host block. It finds the matching block and uses the document root from that block to know where to find files. Example.com maps to /var/www/example. Another site.com maps to /var/www/another. The server alias directive lets you match multiple domains or subdomains to the same virtual host. Both example.com and www.example.com can share one block. Step 4. Apache processes the request. Apache looks at the file extension. If the path is /index.html, static file, Apache reads it directly from disk and queues it for sending. If the path is /index.php, PHP file, Apache passes it to the PHP engine via mod PHP or PHP FPM for execution. Step 5. The application runs. For Laravel, the htaccess file in the public folder rewrites every request to index.php. Laravel bootstraps, the router matches the URL to a controller, the controller calls the model queries MySQL, and the view renders the HTML response. Step 6. Apache sends the HTTP response. Apache takes the output, whether it is a static file or the HTML that PHP generated, and wraps it in an HTTP response. The response starts with the status line, http://1/1 200 OK means success. Then come the headers. Content type tells the browser it is receiving HTML. Content length tells it how many bytes to expect. Then comes the body, the actual HTML. HTTP status codes tell the browser what happened. 200 success, 301 is a redirect, 403 forbidden, 404 not found, 500 is a server error from a PHP crash or misconfiguration. 6 steps every request takes. Browser sends HTTP request, Apache receives it on port 80 or 443, virtual host block is selected by matching the domain, Apache routes to a static file or PHP, the Laravel application runs, route, controller, model, view, Apache returns the HTTP response with status code and body. When you deploy an Apache server, you need to know where everything lives. Where do the config files go? Where do website files go? How do you activate a site? How do you tell Apache to allow htaccess? This chapter maps the complete directory structure and explains every important config file. All Apache configuration lives under etc/apache2. The tree has a clear structure. Apache2.conf is the master configuration. It sets global server behavior and includes all other files. Ports.conf controls which ports Apache listens on. Sites available holds one .conf file per website you have configured. Sites enabled holds symlinks to the configs that are currently active. Mods available lists all installed Apache modules. Mods enabled holds symlinks to the modules that are loaded. Actual website content lives in far/www/, each site in its own subfolder. For Laravel, the document root must point to the project's public directory. Apache2.conf is the global master config. It sets the request timeout, 300 seconds by default. Keep Alive on keeps TCP connections open for multiple requests. Max Keep Alive requests caps how many requests one connection handles. Log level controls what goes in the error log. Server tokens prod hides the Apache version from response headers. Always set this in production. Ports.conf is simpler. It just lists the ports to listen on. Listen 80 is always present. Listen 443 is wrapped in an if module block, so it only activates when mod SSL is loaded. Each website gets its own .conf file and sites available. The file name is typically the domain name, myac.conf. Inside is a virtual host block with server name for the domain, document root pointing to the public folder, and a directory block that grants access and enables htaccess. To activate a site, run sudo a2nsite myapp.conf. Apache creates a symlink from sites available to sites enabled. Run sudo a2dissite to deactivate. The config file stays untouched. Always run sudo apache2ctl config test before reloading. A syntax error in the config will prevent Apache from restarting. The directory block applies configuration to a specific folder on disk. 3 directives matter most. Allow override all enables htaccess files. Apache reads the htaccess in each directory on each request and applies its rules. This is required for Laravel and WordPress routing to work. Require all granted allows Apache to serve files from that directory. Without it, Apache returns 403 forbidden. Options minus indexes prevents Apache from showing a directory listing when no index file exists, a security best practice. Setting allow override none disables htaccess entirely and is faster because Apache never has to read the htaccess file on each request. Config lives in etc/apache2. Apache2.conf sets global behavior, timeouts, keep alive, server tokens. Ports.conf sets listen 80 and listen 443. Sites available stores 1.conf per site. A2N site creates the symlink and sites enabled to activate it. Always test config before reloading. Allow override all enables htaccess, required for Laravel and WordPress. 4 chapters to go. One Apache server can host hundreds of websites simultaneously. Each gets completely isolated configuration. And every feature Apache has, URL rewriting, HTTPS, compression, proxying, is an optional module you load only when needed. This chapter covers virtual host blocks and the most important modules for PHP development. A virtual host block is the fundamental unit of per-site configuration. Server name is the primary domain Apache matches against the request's host header. Server alias adds additional domains. www.myapp.com maps to the same block as myapp.com. Document root is the folder Apache serves files from. Always point this to Laravel's public directory. Error log and custom log give every site its own log file. Always set these because when something breaks in production, the log is the first place you look. Apache's core handles basic HTTP. Every additional feature is a module. Mod URL rewrite transforms URLs, essential for Laravel and WordPress clean routing. Mod SSL adds HTTPS, required in every production environment. Mod headers adds and modifies HTTP response headers, used for cores and security headers. Mod deflate compresses responses with gzip. HTML, CSS, and JavaScript shrink by 60 to 80%. Mod proxy turns Apache into a reverse proxy, forward requests to node.js or any other backend. Enable with A2EN mod SSL. Disable with A2 dismod SSL. Restart Apache after any module change. Mod URL rewrite intercepts URLs before Apache serves anything. The htaccess file in Laravel's public folder uses 3 directives. Rewrite engine on activates the rewriting engine. It must appear first. Rewrite con %request file name !f is a condition. Only proceed if no real file exists at this path. Rewrite rule index.php LQSA bracket rewrites the URL to index.php, Laravel's entry point. The result, every URL like users/profile, products/123, API/orders routes through index.php, and Laravel's router handles the rest. Critically, allow override all must be set in the directory block. Without it, Apache ignores htaccess entirely, and every clean URL returns 404. Mod SSL adds TLS encryption to Apache. Enable it with A2EN mod SSL. Then configure a virtual host on port 443 with SSL engine on, SSL certificate file pointing to your certificate, and SSL certificate key file pointing to your private key. The easiest way to get a certificate is certbot from Let's Encrypt. It is free, auto-configures Apache, and auto-renews every 90 days. One command, sudo certbot -apache -d yourdomain.com. That's it. Free HTTPS in under a minute. Virtual host isolates each site. One block, one domain, one document root. Mod URL rewrite enables clean URLs, requires allow override all. Mod SSL adds HTTPS. Use certbot for free certificates. A2EN mod loads modules. Restart after changes. One Apache server, unlimited sites, features loaded on demand. htaccess is a plain text file that gives you Apache configuration without touching the server config. No sudo, no restart. Drop the file in a directory and it takes effect immediately. This chapter covers everything htaccess can do. URL rewriting for Laravel routing, redirects for SEO, forcing HTTPS, and the performance trade-off you need to understand. htaccess is a per-directory configuration file. Apache reads it on every request, not just on startup. It applies to the directory it lives in and all subdirectories below it. In a Laravel project, htaccess lives in the public folder, the document root. This means it runs for every request to the application. Changes are instant because Apache reads it fresh each time. You can modify routing behavior without ever touching the server configuration. The requirement is allow override all in the virtual host's directory block. The Laravel htaccess starts with options -multiviews -indexes. This disables Apache's content negotiation and directory listing. Rewrite engine on activates mod rewrite. This must appear before any rewrite rules. The first rewrite cond handles core's pre-flight options requests by returning a 204 response immediately. The critical pair, rewrite cond %request filename !f, checks if the path is not a real file on disk. If the condition passes, rewrite rule index.php (L) routes the request to index.php. The result, static files like style.css are served directly. /public/style.css exists on disk. The condition fails, no rewrite happens. All other requests go to index.php and Laravel handles routing. The redirect directive handles URL changes. Redirect 301/old page/new page is a permanent redirect. Browsers and Google update their records. Old bookmarks and links automatically forward. Use 301 when permanently moving content. Use 302 when the redirect is temporary. The most common production redirect is forcing HTTPS. Rewrite cond %HTTPS off if the request came in unencrypted, redirects to the HTTPS version of the same URL using %HTTP host and %request URI to reconstruct the full URL with r = 301 L for permanent redirect. Other useful patterns, redirect www to non-www to avoid duplicate content in search engines, and error 404/404.html for a custom not found page. Here is the performance trade-off. Apache reads htaccess from disk on every request. Not just once, it checks for htaccess in every directory in the path. A request to /var/www/myapp/public/style.css causes Apache to check /var/var/www/var/www/myapp and /var/www/myapp/public for a htaccess file. That is 5 disk reads per request. The fix is set allow override none on the root /var/www directory and allow override all only on the specific public folder that needs it. This eliminates all the unnecessary htaccess checks up the path. WordPress generates its own htaccess automatically from the settings permalinks page. The pattern is identical to Laravel. Check if it's a real file, check if it's a real directory. If neither, route to index.php. htaccess is read on every request. Place it only where you need it. Rewrite engine on activates rewriting. Rewrite cond sets conditions. Only rewrite if they match. Rewrite rule transforms the URL. Routes to index.php for Laravel. Redirect 301 is permanent, SEO safe. Allow override all must be set in the directory block. Disable .htaccess everywhere except public for best performance. Apache's most important job in most PHP shops is running Laravel, WordPress, and other PHP applications. This chapter covers the two ways Apache runs PHP, the complete virtual host configuration for Laravel, all 4 AMP components and their roles, and the one security rule that protects your entire application. Apache can run PHP 2 ways. Mod PHP embeds a PHP interpreter directly inside every Apache worker process. Install libapache 2 mod PHP 8.2, and PHP is immediately available to Apache. No additional configuration. Simple. But every Apache worker process carries PHP's memory footprint even when serving a static CSS file. PHP FPM, Fast CASI Process Manager, runs as a completely separate service. Apache sends PHP requests to PHP FPM via a Unix socket or TCP port. Memory efficient. PHP only starts when a PHP file is requested. Supports running multiple PHP versions simultaneously for different sites. Enable it with sudo a2nmod proxy fcgi set env, then sudo a2nconf php 8.2/fpm. PHP FPM is the modern production recommendation. The complete virtual host has 6 key parts: the opening tag with port 80, server name with the domain, document root pointing to the public folder, this is the most critical line, a directory block covering the project root with allow override all to enable .htaccess and require all granted to allow file serving, error log and custom log for per-site log files. Document root must point to the public folder, not the project root. Allow override all enables .htaccess so mod rewrite can route requests to index.php. Require all granted gives Apache permission to serve from that directory. The log files are the first place to look when a 500 error appears in production. 4 components, 4 jobs. Linux is the operating system. It hosts everything, manages files, processes, and the network. Apache is the web server. It receives all HTTP requests, routes to PHP or serves static files directly, handles SSL, rewrites, and headers. MySQL is the database. It stores users, posts, orders, sessions, anything that needs to persist. Laravel queries MySQL via Eloquent using the credentials from .env. Apache never talks to MySQL directly. PHP and Laravel together are the application, running inside Apache via mod PHP or PHP FPM, handling routing, business logic, and generating HTML responses. This is the most important security rule in any PHP deployment. The document root directive must point to Laravel's public folder, var www.laravel.public, never to the project root. If you point it to var www.laravel, every file in the project is web accessible. A visitor can go to yoursite.com/.env and read your database password, your API keys, your mail credentials, all in plain text. Setting document root to the public folder means only the public folder is accessible. Everything above it, .env, app, config, routes, database, vendor, is above the web root and completely inaccessible from any browser. Apache runs PHP via mod PHP for simplicity or PHP FPM for efficiency. Document root must always point to public/hides.env and all source code. Allow override all enables .htaccess, required for Laravel's mod rewrite routing. The lamp stock. Linux runs Apache, Apache runs PHP, PHP runs Laravel, Laravel queries MySQL. 4 components, 1 production application. The final chapter. 3 things: securing Apache against information leakage and common attacks, optimizing performance with compression and caching, and the complete LAMP production checklist. 7 chapters of Apache. This is everything you need to deploy a PHP application to production. 2 critical security settings. First, hide server information. By default, Apache includes its full version string in every response header and error page. Server Apache/2.4.54 Ubuntu. Attackers use this to search CVE databases for known vulnerabilities in that exact version. 2 lines in apache2.com fix this. Server signature off removes the version from error pages, and server tokens prod reduces the server header to just Apache with no version. Second, disable directory listing. Options-indexes prevents Apache from displaying folder contents when no index file exists. Add a files match block to deny access to any file starting with a dot. This blocks direct access to .env, .git, and any other hidden files, even if they end up inside the web root. 2 modules transform Apache's performance for production. Mod deflate enables gzip compression. Enable it with A2EN mod deflate, then configure add output filter by type to compress HTML, CSS, and JavaScript. These file types compress by 60 to 80%. A 200 kilobyte JavaScript file becomes 40 kilobytes. The browser decompresses it instantly. Users see faster load times. The server sends less data. Mod expires adds browser cache headers. Enable with A2EN mod expires. Set expires by type for different file categories. CSS and JavaScript cached for 30 days. Images cached for a year. A returning visitor's browser never requests those files again until the cache expires. Max request workers sets the maximum number of simultaneous connections Apache handles. With pre-fork npm, each worker is a separate process. 150 workers means 150 simultaneous connections. 150 first request waits. Calculate max request workers from your server RAM. If each Apache process uses 50 megabytes and you have 4 gigabytes of RAM available, set max request workers to around 80. Keep alive on keeps TCP connections open for multiple requests. Without it, loading a page with 20 assets, HTML, 5 CSS files, 10 JS files, and 4 images requires 20 separate TCP handshakes. With Keep Alive, 1 connection serves all 20. Max Keep Alive requests 100 caps how many requests per connection. Keep Alive timeout 5 closes the connection after 5 seconds of idle, balancing performance against holding connections open too long. The complete LAMP production stack. Browser sends an HTTPS request. Apache receives it with mod SSL, terminating the encryption. Mod RW read processes the URL via htaccess. The request routes to index.php. PHP or PHP-FPM executes Laravel. Laravel queries MySQL via Eloquent. The response flows back through Laravel, through PHP, through Apache, encrypted back to the browser. Before deploying any Laravel app to Apache, run through this checklist. Document root pointing to public/dot. Allow override all in the directory block. Enable mod RW, mod SSL, mod deflate, and mod expires. Set server tokens prod and server signature off. Run certbot --Apache for free HTTPS in 1 command. 7 chapters. The complete Apache picture. Chapter 1, the LAMP stack and Apache's role. Chapter 2, the 6-step request lifecycle from browser to response. Chapter 3, the etc/Apache2 directory structure and every config file. Chapter 4, virtual host blocks for multiple sites in the essential modules. Chapter 5, htaccess URL rewriting, redirects, and the performance cost. Chapter 6, Mod PHP versus PHP-FPM, the complete Laravel config and the public folder security role. Chapter 7, Hiding server info, gzip compression, browser caching, worker tuning, and the production checklist. Hide server version, disable directory listing, compress with deflate, cache with expires, tune your workers. Apache powers the LAMP stack, WordPress, Laravel, and most of the web.